He is right. I sent those.
You what?
I, at the start of the semester, took a bunch of oranges,
Oh.
shredded it to get the zest,
Yeah.
and just put the aroma in. Okay, dokie. So, okay, how do I want to? All right, so today we're going to talk about the inverses of square matrices. Before we get into that, I got two bell work problems for you today. Tell me what 1, 2, 3, 4 times 1, 0, 0, 1 is, and then solve this system of equations either traditionally or using the Gauss-Jordan elimination method, or new thing, Kramer's rule from last class. Give you 3 minutes. Okay, so does anybody have the first one here? Anybody? Got the first one? It's pretty good. Okay. I'll roll the dice. See who's gonna help. Roll the dice. Okay, let's do, that's 4 of you, so this will be pretty easy. Let's roll a d4. 3. 1, 2, 3. Hi, Anna. All right. So can I multiply these two matrices together?
Yeah.
Was it not even showing this? No, wait, that's the wrong. Okay, it was. Whew, okay, yes, I can. They're both 2 by 2s, right? So the number of columns in the first one is equal to the number of rows in the second. These two numbers match. So my answer will be a 2 by 2. How do I get this first element?
So you do the 1 times
Mhm.
1
And
times 2 times 4.
that's right. Take the first row, first column. So I take first row, first column. 1 times 1 is 1. 2 times 0, 0. And then 1 plus 0 is 1. Neat. How do I get this one?
Do the 1 times 0, 2 times 4.
Yeah. So I'm going to do the first row by the second column now. First row, second column. So 1 times 0 is 0. 2 times 1 is 2. Neat. Okay, now I've got a real trick question for you. How do I get that one?
So 3 times the 1 and then 4 times the 0.
Yeah. Second row, first column. Second row, first column. 3 times 1 is 3. 4 times 0 is 0. So this is 3. Last one. How do I get that one?
3 times 0 is 4 times
Which is 4. And would you look at that? That was the one we started with. That's because this matrix is the identity matrix, right? Remember, it has a 1 in the diagonal and zeros everywhere else. And any matrix times the identity matrix is itself. Neat. All right, number 2 here. We can solve this in the calculator. How do I do this? Stop share, reshare, whole screen. Okay, put this here, calculator here. Very good. All right, so to do that, first thing we need to type in is second matrix. Go to edit, and we're going to edit matrix A. So it's a 3 by 3, where the first column is my x coefficients, the second column is my y coefficients, and the third column is my z coefficients. So my first row would then be 4, -1, 1. 4, -1, 1. My second row, using the second equation, would be 2, 2, 3, 2, 2, 3. The third row, using my third equation, would be 5, -2, 6. 5, -2, 6. So that gives me a coefficient matrix. I am then going to take the determinant of that. So if I hit second matrix, go to the math tab, the first operation here will take the determinant of my matrix. I need to tell it what matrix to use, so I'm going to go second matrix. And then I'm going to tell it to use this first matrix A. Enter. So that tells us that D is 55. The determinant of my coefficient matrix is 55. I need to find now dx, dy, and dz. To find the determinant with respect to x, I'm going to replace all of my x values with the constants 12, 1, and 22. So I'm going to hit second matrix, go back and edit matrix A. So now instead of 4, 2, and 5, I'm going to put 12, 1, and 22. I'm going to replace all the x's with the constants. And then the nice thing about this is once you have it typed in, you can just hit enter and it will repeat this previous command to take the determinant of matrix A. So that is 110. To get the determinant with respect to y, I'm now going to replace all the y's with the constant 12, 1, and 22. So I'm going to go back in, edit matrix A. Note that I need to switch the x's back. So this needs to be 4. This needs to be 2. And this needs to be 5. And then I'm going to switch the y's now to be 12, 1, and 22. All right, and quit. Hit enter. dy is negative 165. And then last I need is dz. To get dz, I'm going to replace the z's with 12, 1, and 22. Matrix. Edit. Note that I need to switch the y's back now to negative 1, 2, and negative 2. And then I'm going to switch my z's to 12, 1, and 22. Quit. Enter. 55. So then my solution is dx over d, dy over d, and dz over d, which would be 110 divided by 55 is 2. Negative 165 divided by 55 is negative 3. And 55 divided by 55 is 1. So those three equations intersect at 2, negative 3, 1. Yay! That's not that bad. And today I'm going to show you an even easier way to do it. Can you believe that? We take a problem that doing this by hand, solving one of these equations for x and then plugging it into the other two, or using elimination to get this system of 3 equations down to a system of 2 equations, and then having to do substitution or elimination again to get one variable and then plugging back in and plugging back in. All can be done now in like 3 minutes if you're typing to yourself, or even less than that, as I'll show you today. So, we're going to do 3 things today. First, verify that 2 matrices are inverses. Determine what, really this is just a definition thing. We have to figure out what is an inverse and how do we know that 2 matrices are inverses of each other. That's not too bad. B here is also not too bad because it's just a formula. So you can find matrices inverses by calculator, but when it's just a 2 by 2, it's probably easier just to do it with the formula. Not too bad. And then this, it might be the easiest thing of all because this is just using a calculator. So I'll show you what you need to type into your calculator. And once you see that, you'll be able to solve a system of 3 equations with 3 variables in less than a minute. All right, first things first. What the heck is an inverse? So if you have a matrix A that is a square matrix, n by n, and we let I represent the identity matrix of the same size, n by n, then if A has an inverse denoted as A to the superscript -1, then what that means is A times its inverse is the identity, and its inverse times A is the identity. And ideally, hopefully, this definition makes sense to you. If we think about it in terms of just regular multiplication, the identity for regular multiplication, you don't have to write this down as 1, right? Because 2 times 1 is 2. Anything times 1 is itself. So for regular multiplication, 1 is the identity, right? For regular multiplication, 2.5 would be inverses of each other because 2 times a half is 1. If you think about this with addition, the identity of addition is 0 because anything plus 0 is itself, right? 2 and -2 are inverses for addition because 2 plus -2 gives us the identity 0. So that's how this works. If A is a matrix that is invertible, then its inverse will be what other matrix you would multiply it by to get the identity where there's 1 down the diagonals and zeros everywhere else. Please note that A inverse is not A to the -1 power. That's not what it is. It's unfortunate that that notation is also used for A to the -1 power, but it's not. It's A with this superscript -1 is read as A inverse, not A to the -1 power, even though that is exactly what it is. Okay. Anybody need more time on this slide? All right. So let me show you an example of what your homework is going to look like then. So your homework is going to say, here's 2 matrices. Tell me if B is the inverse of A. To test whether or not that's true, I am going to multiply them to see if I get the identity matrix. So I'm going to multiply B times A, and I'm going to see, well, what does that equal? Is that answer the identity matrix 1, 0, 0, 1? If it was a 3 by 3, I would say, is it 1, 0, 0, 0, 1, 0, 0, 0, 1? Is it that? Right? That's the question. So first, is the operation defined? Yes, I've got a 2 by 2 times a 2 by 2. So these numbers match. So this is defined. The result will be a 2 by 2. So far, so good. To find out what this is, let's start with the first element here in the first row, first column. To get that element, we're going to take the first row. We're going to multiply it by the first column. So it'll be 1 times -1 and -2 times -1. So that'd be what? -1 plus 2 is 1. To get this element, I'm going to take the first row, second column. So first row, second column. 1 times 2 is 2. -2 times 1 is -2. So 2 plus -2 is 0. Yay! So far, so good. To find out what goes here, second row, first column. Take the second row, first column. 1 times -1 is -1. -1 times -1 is +1. -1 plus +1 is 0. Great. Last element down here, second row, second column, second row, second column. 1 times 2 is 2. -1 times 1 is -1. 2 minus 1 is 1. Is that the identity matrix? You bet. So that means that A is the inverse of B, and B is the inverse of A. They are inverses of each other. If I multiply them together, I will get the identity matrix 1, 0, 0, 1. Isn't that cool? That's cool. I like the identity matrix. I think it is aesthetically pleasing matrix to look at. If I could, I guess there's nothing really that's stopping me. I should go to Wolf's and have them blow up like the 10 by 10 identity matrix and just put it on the wall in here. And everyone will look at that and be like, that is pleasing. It's nice. Okay, your turn. Are these two matrices inverses of each other? I wonder. Well, see if you can find out. Multiply them together and see if you get 1, 0, 0, 1. And don't forget, if you you can always verify your answer in your calculator to make sure they are multiplying to be what they should be. Okay. Okay, that's what I was doing. All right, are they inverses? Let's do it. Okay. 2, -1, -3, 1. Why am I rewriting? I don't need to rewrite this. I'm going to put a big time sign in here. Okay, equals. It is defined 2 by 2. So I'm going to take first row, first column. So that'd be -2 plus 3. That's 1. -2 positive 2. 0. Won't work. Second row, first column. Positive 3, -3. So that's 0. and then positive 3, negative 2. So that's 1. So it does turn out that they're okay. The negative signs on these are really fiddly. So you should, that's why I say you could double check in the calculator. You should. Doesn't take that long. Type it in and type multiply. Because those negative signs, they'll get you. 90%, even like 95% for the errors made in this class are negative signs. All right, so that's how you verify if two matrices are invertible. Now, how do you find, well, how did they come up with this other matrix? So for a 2 by 2, you can do that by hand. Please note, though, that a matrix is invertible if and only if its determinant does not equal 0. If the determinant of your matrix is 0, it is not invertible. All right, well, if it's not 0, you can find the inverse by taking 1 over the determinant, and then you have to multiply it by this weird transposition of A. You have to flip A and D so they're in their opposite spots, and then you have to change the signs on B and C. So it's kind of a weird formula, but you're going to take the determinant of A, and you're going to put that under 1, and then you're going to multiply that by this weird transposition. And hopefully you can see why now we say the determinant can't be 0, because we're dividing by the determinant, you can't divide by 0. For all square matrices, 2 by 2 and bigger, you can find their inverse super fast in the calculator by just pressing the inverse key. I will show you what that looks like after we do an example. Got a YouTube video that I need to edit down. I always forget how I'm supposed to do that. Editor, that's it. Okay, good to go on? Anybody need more time? Sweet. All right, so let's do an example. All right, I'm going to find the inverse of each of these matrices. So to do that, first matrix is 3, -1, -2, 2. Second matrix is 3, -1, -6, 2. I'm going to then say that the inverse of A is equal to 1 over the determinant. So cross multiply and subtract. So that'd be 6. That'd be plus 2. So this will really be minus 2. And I'm going to multiply that by this weird transposition. So flip A and D. So this becomes 2, 3. And then I change the signs on the other two. +1, +2. So basically 6 minus 2 is a fourth. So I'm going to take a fourth of each of these numbers. That'll get me 2/4 is a half. 1/4, a half, and 3/4. That is the inverse of A. For matrix B, same thing. Its inverse will be 1 over the determinant of 6 minus, positive 6. Oh no, that's 0. So this is, I don't need to do any more. This is not invertible. I think I spelled invertible with an I here for our first hour, and nobody said anything. But then again, nobody in first hour says anything ever. They are twice as big as this class. And they just refuse to, they don't want to. No volunteering, no questions. Always have to roll the dice. Roll the dice. Okay, yay? All right, so I told you could do this in a calculator. Again, you can see for this one, by hand is pretty nice, but when it gets to be a 3x3, you have the formula becomes a lot more complex. And it's just, to be honest, it's just not worth it. So let me see to show you how to do this in a calculator. So stop share, reshare the calculator, the whole screen. So if I split this between this and my calculator, all right, so if I go onto my matrix, I'm going to make a new matrix C. So if I type in matrix A, it's a 2x2, elements 3, -1, -2, and 2. If I go into second matrix and I grab matrix C, I can take its inverse by just pressing that same key we've been doing this whole time. I'm just not going to hit the second. I actually want to do x to the -1 power. So I just click that. Enter. A half, a quarter, a half, 3/4. Like that. If I wanted to take the inverse of matrix A earlier, the 3x3, again, by hand, that's going to take forever, but by calculator, boom. Kind of like that. Now you do have to like scroll over to get to see this, or you might have to like, you do sometimes run into a window issue where you can't see the last 2 elements, but I believe you could store this. How do I do that? How do I do that? There's a way to do that. I'll have to figure it. I'll have to look. I don't think you have to worry about it for any of yours. The easiest way is to change this float to only give you like 3 decimals, and then it'll fit in your screen. There's another way to do it too. See it? Program? No. Apps? No. I'll figure it out and tell you later. Okay. Back to this. Your turn then. Find the inverse. Well, hold on. No, not your turn. I want to make sure we get this done. So we'll come back to that kind of practice if you want. For subpoint D, I do want to make sure I lecture over this, how to get a system of linear equations solved with inverses. And all you really need to write down is this. Your solution X is going to be the inverse of A times B, where A inverse is the inverse of your coefficient matrix. and B is a column of your constant matrix. So it's your constants written into a column matrix. So it'll be like if it was 3 equations with 3 variables, it would be a 3 by 1. If it had 5 equations with 5 variables, it'd be a 5 by 1. It's just all the constants that you have at the end of each of those equations written in a column. Inside EC. I'll give you 3 minutes. Inside EC. I'll give you 3 minutes. Inside. So, for the first one, it's going to be tough to edit that. Okay, good with this? Okay. Boom. All right, let's do an example. You'll see, I'll be able to do this example in 1 minute. All right. So to do this example, I'm going to hit second matrix, and I'm going to edit my first matrix here. I have 3 equations with 3 variables, so I want it to be a 3 by 3. And I'm going to enter my coefficients into this matrix. So the first one is 2, 3, 1, 2, 3, 1. Second one is 3, 3, 1. I have 3x, 3y, 1z. Again, I want x, y, z, so 2, 4, 1. 2, 4, 1. Yay. All right, then I'm going to go back in, and I'm going to edit a second matrix. As you can see, I already did this for my earlier hour. That's a 3 by 1. And I'm going to enter my 3 constants into here. -1, 1, and -2. To get my answer then, I'm going to take matrix A, invert it, and multiply it by matrix B. That's the answer. They intersect when x is 2, y is -1, and z is -2, or at the point 2, -1, -2. See how fast that was? Even with me talking through it, it was literally a minute. When you do the ACT, if they give you systems of equations, you could do this for a 2 by 2. You could do this for a 4 by 4. Get your equations in the right order so that you can type it in really quick. Type it in. To be honest, you could probably do this in 30 seconds and save yourself a little bit of time on another problem. Questions? All right, see if you can do this one. And then that'll be the end of class. Oh. Negative 210 or negative 217. Isn't that cool? That's cool. It's so much better. All right, see you all Tuesday. Have a good 3-day weekend. Online next week, probably till like March. Yeah. Bye.